Good morning or good afternoon, depending on where you're logging in from in the world, and welcome to today's workflow webinar with DotProduct and Intel RealSense, demonstrating some of the very latest in handheld 3D scanning hardware and software, and the new capabilities for capturing even in bright sunny conditions using Intel RealSense technology. We encourage you to submit any questions at any point via the GoToWebinar window on your screen, and we will do our best to address them all at the end of the session. If we don't get to your question, don't worry. We will definitely follow up directly via email as well. As I say at the beginning of all of our webinars, we like to do everything live here at DotProduct, so please bear with us if there's any glitches along the way, but hopefully everything goes smoothly and you'll get to see a very impressive live scan using Intel RealSense from the same device that we're presenting on right now. First, I'd like to introduce myself, Chris Ahern, Marketing, Sales, and Product Manager here at DotProduct, and a specialist when it comes to these workflow webinars and live presentations of our technology. I'm here with Brian Pruitt from Intel, who will take it away.
Hi, this is Brian Pruitt. I'm the Director of Product and Partner Marketing at Intel and the RealSense team. Thanks. Hi, let me introduce RealSense to you. Hey, let me talk to you about what our vision is for our team. RealSense is a small business unit inside of Intel. It's in our emerging markets and growth group. What we are doing is trying to bring senses to all the devices so that they can perceive the world the way that we perceive the world. We believe this is the best way of making these devices smarter and more useful to the consumer. If you go to the next slide. The way we're going to do this is we're looking at all the different segments and seeing best where we can add value. And our first value that we're really targeting is vision. We believe vision is the next natural step for these devices. And this is where we have our RealSense technologies. To give you an idea of where we're at today, so RealSense has been around for over 10 years in the think part, and then we've been a business group for a few years since then, and we've tried several markets. Today, what we've done is we have cameras that are in all of these markets that you see here. Of course, we have 3D scanning like DotProduct's going to show you. It's a great pairing of our product and their technology to give you something unique that a 2D camera cannot do well. We are in 3D face control. We're in robots, of course, surveillance, AR, people tracking. All of these are actual devices that we have design wins in. It's amazing how this market is continuing to grow, and we're finding more and more interesting use cases, such as the latest one is to monitor chickens' health. So we are finding some interesting uses to this depth camera. The way we do this is we put together a great set of products to meet all the needs. So we start off with our cameras. Our cameras are all self-contained. They're very easy to use. It's to allow the developer to take this out of the box, plug it into a device, and to see if the camera is going to work in the environment. Our goal is to do this under 5 minutes after getting the device out of the box. Once they figure out that the device works for them, the next step is to decide whether they just want to use the camera in their product or they want to embed the camera into their product, whichever works best for them. The modules and that ASIC board underneath are the intelligence and the hardware needed to do the 3D. And this is what a lot of companies will tend to go to when they're doing higher volumes. On the left, we have the vision processors. The vision processors are the brains. It's our IP on how we calculate depth. Very low power, very powerful processor that if the partner that we're working with decides to build their own 3D camera, they can, and they could use our chip to do the calculations. To make all of this work together, we have this cross-platform SDK. This cross-platform SDK allows you to start with any of our cameras and move to another camera with the smallest of lifts. The design is to be forward and backwards compatible so that the camera you use today won't become or the code that you use today with our camera doesn't become obsolete. It can go from generation to generation camera as we improve the technology. And of course, as any good SDK should have, it has some vision libraries for samples. This is a good view of all the products that we're offering today, plus a little sneak preview of the SR305, which is in the upper right-hand corner. This is a camera that we have not announced yet. We will announce it soon. It will launch very shortly. It is a coated light camera that we are basing on a technology that we were using before only in a developer form. Now we're making a full productized camera like the rest of our cameras. It will be a low-cost entry into our family. We also, you'll notice the tracking camera up at the top. This is our step of expanding from just vision. Now we're giving awareness of where you're at. So this is a camera that uses a specialized version of SLAM running on a Movidius chip that can tell you where you're at in a space. Think of it as a handheld GPS, which is a good analogy for it. Very accurate, very good for robotics and for AR/VR. To the left of that, on the top side, you have our stereo cameras. These are what DotProduct uses with their current products. As you see, the 415, 435, 435i, all different versions of it to meet whatever need that you have. And then, of course, the bottom shows all of our embedded products. We have partners out there that are taking these and actually putting them into tablets or PCs like Mobile Demand or Panasonic, to name just a couple. We'll touch upon those in a little bit. But this is our product. It's going to grow. We're going to have some exciting announcements later in this year of some new products that I think are revolutionary. I want to thank DotProduct for letting us be part of this. I think they have an amazing product. We've even had them talking to our internal teams. We like the idea of what they're doing, and they pair very well with our technology. And with that, I'll pass it back to Chris.
Thank you, Brian. That was a great intro to Intel RealSense. We've been highly involved with the RealSense program from the start and are very excited by what we're seeing today and the directions that you guys are headed in going forward. To kick things off on the DotProduct side, I just have a brief introduction to our team. We are a global company focused exclusively on handheld 3D data capture from mobile devices. We're headquartered here in Boston, with an office also in Wiesbaden, Germany, and Houston, Texas. We also partner worldwide with resellers, software, and hardware partners like Intel. Here you see our list of our core product lineup. We have been delivering the DPI line of products for coming on 5 years now. And this is a complete solution Android-based tablet kit with the PrimeSense sensor calibrated and built into the device. We continue to sell that product line, but we're also, as we always have, really honing in on and focusing on the fact that we are at our core a software company. And in the world of Intel RealSense, that really comes into play. So what we're going to be seeing today in bold here on the screen is our Dot3D Pro application operating on Windows. And we have two different variants of that, Pro and Scan. And in any case, those are what are utilized with the Intel RealSense technology for capture. So here's another slide that outlines that a little bit better. So Dot3D Pro is our complete professional solution. It includes all of our scanning and editing functionality, and it's what the vast majority of our customers are utilizing for their capture, whether it be on a DPI 8S, Android-based scanner, or whether it be on a Windows device with Intel RealSense as we're demonstrating here today. The scan version is a bit more of an entry-level version, smaller scene size capture, a lot less of the advanced features, but definitely another good option for getting started with the technology. Although for larger scene capture, you will need the professional version. We're really trying to make it very, very easy for our customers to manage, edit, and share their data throughout their organizations and others. So we also have the view and edit versions of Dot3D, all cross-platform on Android or Windows. And this allows for a very affordable point cloud editing and management solution. You'll see a lot of that editing functionality today, which is also included in Pro. And then we also have a completely free viewer version on Android and Windows so far that allows you to easily share the data with someone else to see all of your captured information, annotations, measurements, and more. So with that, I'll touch base a little bit on what we're actually going to be demonstrating today. This device that you see here on the screen is actually the same exact device that I'm broadcasting this entire webinar from today. So we're really doing it all live. We're operating Dot3D Pro on a Microsoft Surface Go tablet with an Intel RealSense D415 depth camera attached to the back. The mounting kit that you see here is something that we've developed to make it a nice, convenient, short USB-C to USB-C cable and a simple magnet attachment for snapping the RealSense on the back of your tablet. Once we finish the presentation here today, I'll be carrying this device outdoors to do a live scan here on the session. But before we do that, I also want to touch base on some of the high-end solutions that are available through our hardware partners. In addition to a simple Surface Go tablet like we're using today, a lot of our industrial customers absolutely prefer some of these more ruggedized professional solutions. These companies are also embedding the Intel RealSense sensors or otherwise ruggedizing them, which is a really nice touch other than trying to snap it on the back of a tablet yourself, although you obviously have both options here. All of these are based in the Windows environment for now, although we do plan to add support for RealSense on Android very soon as well. First off, we have the DT Research DT301X today, as well as their upcoming lineup of rugged GNSS tablets. So these highly rugged tablets not only have the option of adding on the RealSense D415 sensor, but they also have the option of adding on a high accuracy GNSS receiver. So this is going to be coming soon also in the next release of Dot3D, where you can actually tie into that GNSS receiver and get global location information when you're scanning outside. It has a lot of really exciting applications that are going to be improved with that, from pipeline scanning to utility work to inspection work, etc. Next, we have Mobile Demand, who are also partnering with DotProduct and Intel RealSense to embed these sensors into their rugged Windows tablets as well. You see that on the screen here, you actually have an embedded version where the RealSense is fully built into the ruggedized design, or you have a somewhat external version where the RealSense itself has been ruggedized. And this is really beneficial if you want to be extending the RealSense on a pole, for example. You're actually obtaining both benefits of a detached RealSense and a ruggedized tablet at the same time. They have quite a variety of options in their lineup that include the option of adding the RealSense, including a couple of ruggedized cases that work very nicely with the same tablet that we're broadcasting from here today. Next, we have Panasonic and their ToughPad lineup. The FZ-M1 is the solution that has the option of a fully embedded Intel RealSense sensor in their high-end, highly ruggedized ToughPad tablet. So a lot of great options out there. In any of these situations, whether it be ruggedized tablets, Android-based scanning, Windows-based scanning, I'm going to now overview our software technology, which is powering all of these different solutions. Our handheld 3D software from the start was developed to achieve all of the goals you see here on the screen. So a truly mobile device that allows you to walk around the area of interest with full freedom of motion. Very simple to use technology that field workers can get up and running with very quickly and easily. It can easily train others in the organization how to use in a matter of minutes. Completely handheld, so not only no tripod, but no long cables, no laptop required. Everything is completely self-contained and inexpensive. As you saw on the slide earlier, starting at only $245 a year for Dot3D Scan, or only $1,000 a year for Dot3D Pro. It's a very powerful and affordable solution. You're getting accurate, reliable results with optional workflows to tie into known measurements or known coordinates within your scene. And you're getting real-time data, so you know what you have in the field. You can see what you're scanning as you capture it, and you can review it on the tablet right away. A little bit more on the core aspects of our Dot3D technology. We're producing dimensionally accurate 3D in real time. We're giving you that feedback as you scan, which is the green and yellow that you see in the image here, and you will also see live during our scanning session. We're producing a highly compressed output format. So .dp files are about 40 times smaller than your traditional laser scan or point cloud files, which makes everything really, really fast, both on the tablet and in your post-processing workflows. As we've already partnered with 30 plus 3D applications, which I'll get to later, that are reading that file format directly. You can immediately view, measure, set your coordinates, crop, annotate, and more right from Dot3D on the tablet. And we have some more advanced workflows for capturing larger areas, adding back to a scan, or adding targeting constraints as well. So a little bit more on those. The append functionality first is a unique capability that allows you, once you've finished one scan, to actually add another scan, even without targets, directly back into that first data set. This can be utilized if you look at your data after capture and you realize, oh wait, I missed something important over there. I want to go add that back into my scan. You can actually build that directly back into the same file on the fly and optimize it all together into a single scan. This also can be valuable if you've maybe maxed out your single scene size, which depends on the capabilities of your specific hardware related to RAM and other items. But you want to capture a larger area. So maybe you finished 1 or 2 rooms and you want to continue on to the next room, and you don't necessarily have targets or cloud-to-cloud registration to tie that in together. You can do it very easily using the append feature as well. Next, we have the targeting workflows. These are very powerful and often implemented by some of our best customers across our product line. What this allows you to do is add information to the software that helps improve the accuracy automatically. This can be as simple as what we're going to do today, which is placing one of these April tag targets at your start point of your scan, and then finishing back at that same start point to close the loop and have the software recognize that I've been to this point, this target, more than once within my scan, and I can align every single point in my cloud a little bit more accurately based off of that automatically registered information. You can also utilize targets to reference a point-to-point distance. So if you take a quick tape measurement or a laser disto measurement and you specify the difference between the distance between those two targets, that'll also be taken into account during the optimization. Lastly, if you have known coordinates in your scene, so survey control or a model that you're pulling points from, you can reference those to target coordinates as well. A little bit more on the editing functionality that's included in the professional version, as well as the editor version without scanning. You have a full screen viewer, some very precise measurement functionality that actually allows you to drag from point to point within a scan and get any point-to-point measurement or also any XYZ measurement based off of the coordinates that you set. You can easily crop and clean your scan, which is great, whether it's a standalone scan that you're trying to clean up, or if it's a scan that you're going to be registering to another data set. You want all of those stray, less relevant points to be cleaned out before you perform that registration. You also have annotation functionality to add notes to any particular point within your scan. Or you can actually flag surfaces and cylinders within your scan as well, which can be useful for pulling perpendicular measurements, for getting area measurements, or for getting diameter measurements for starters. In addition to the DP file format, which is highly compressed and convenient, we do also export to 9 other industry standard point cloud formats. So virtually any 3D application that will work with laser scan or point cloud data will work with DotProduct data in one of these formats. You can also toggle between ortho and perspective view, which is very useful for floor planning or cropping functionality, and you can manage your coordinate system on the fly. Another very exciting new feature that's been built into our latest releases is the design comparison functionality. So this is allowing you to take a piece or a full CAD model in an OBJ format, load it directly onto your tablet, say before you go scan or back in the office afterwards, and you can actually perform an in-field registration with the tap of your finger to corresponding geometry or planes in your scan versus the CAD, and then actually do a heat map comparison to see what's different between the actual existing conditions out in the field and the CAD model as it was designed. So we're really excited about this functionality, and we're going to be building more into that feature as time goes on. So as mentioned earlier, we have already partnered with 30 different applications to read the DotProduct DP file format directly. So those are being listed out on the screen as you see here. And then we also do export to all of those industry standard formats for maximum compatibility. And we partner up with a wide variety of companies. We're trying to get this DP format spread as fast as possible. So you see CAD companies here, meshing companies, point cloud registration companies, and more, VR, AR. And we're really excited to partner up with as many of these leading applications as possible and really spread the use of the DP file format. So with that, I'll discuss a little bit on some of our commercial use cases today. This applies across our suite of products, and then I'll move into several image examples of the RealSense in action and how it's being deployed and tested across applications today for especially outdoor 3D capture, which is one of the major benefits of the RealSense, and in particular the D415 that we're showing today, versus any of our products in the past. We've always been limited in a way in terms of outdoor 3D capture because our sensors have been heavily reliant on infrared, which gets washed out on a sunny day. However, with the assisted stereo that we see here with the RealSense depth cameras, we're really excited to see that it works great even on a bright sunny day. So this is opening up a lot of applications that have been closed doors to us in the past. But it's, of course, working indoors just as well, and we're seeing, all sorts of applications opened up by the affordable, Windows-capable, daylight-capable sensors from Intel. So our list of customer base is up on the screen here. This is just some of them, believe it or not. It's a very wide and growing list. And in many ways, I view it as two segments. And this is the first half here that you see on the screen is the traditional laser scanning world. So industries that are experienced with 3D capture or with 3D in general. So whether that be laser scanning or CAD or both, those are your engineering, construction, shipbuilding and naval architecture, industrial facility management, and utilities to a degree. And they see a lot of value in a much more portable, easily deployable, and affordable solution that can be deployed alongside some of the more high-end solutions that they may already have. The second half of the list here touches upon situations that are very exciting to us, where we may be replacing what would otherwise just be a photograph, tape measure, sketchpad type situation. And this is of major value with products like the Intel RealSense, which you can buy today for $150 from Intel. So this is your crime scene forensics, archaeology, digital heritage preservation, inspection and asset management, custom design and installation, real estate, and other applications where we're replacing sketchpad, tape measure type applications. Getting so much more very easily in a small form factor. So here's some images of some of the different applications that we just touched upon that are really exciting for the products that we're showing today. This is an example of a pipeline scan, so capturing all of this important information for utility work before the ground is filled in. This is exciting also for the GNSS possibilities that we're seeing implemented by partners like DT Research. And here we see some of the resulting data from just a quick scan, single scan using a Windows tablet and Dot3D Pro of that pipeline work. Here we see an example of utility work. So this is capturing on an active utility construction site all of the chalk and all of the information on location of different utilities in our infrastructure and capturing it so much more quickly and more detailed than ever before if this sort of information had even been captured at all. And some images of the resulting data shown in Dot3D. You'll see the annotation feature later as we demonstrate this live, as well as the measurement functionality. Another very powerful aspect of the RealSense technology is the fact that it is so small, so lightweight, it's really easy to put on the end of a pole. So in this case, we're looking at a two-man job with one person operating the tablet, watching the data as it tracks through the underground manhole, and the other person operating a pole. There's a lot of possibilities here that we're really excited about. And this is, by far the easiest way ever that we're documenting this sort of information that in many cases has never been documented in any form before. And another image there as well. We're also really excited to open up daylight capabilities for accident reconstruction applications. So with our existing technologies, we've definitely found a nice fit in terms of crime scene mapping and forensic reconstruction for indoor spaces, but there's always been this major limit with outdoor spaces. So now with the RealSense technology, you can capture a vehicle in the middle of the expressway, for example. While vehicles are some of the hardest objects to capture with any laser scanning or 3D capture solution, especially on a sunny day, the RealSense is still doing some of the best work that I've seen on a vehicle, even in the middle of a parking lot in Texas, as shown in the image here. And there's an example of the resulting data from that exact capture session on a very bright day in the middle of a lot. And here's another image example. These ones, of course, are just parked in a lot here, but imagine that you're just trying for reconstruction purposes to get a very quick, very easy scan that shows the direction and pose of each of these vehicles after the crash. You're getting so much information so quickly and easily. Here's another example of the more traditional crime scene scanning application that fits a wide variety of our product lineup, being captured here on a Windows tablet. Another world that we've always fit in very nicely is capture of complex, tight rooms in industrial facilities. So this is an HVAC room that's being captured with the Intel RealSense, and here with a mobile demand ruggedized version of a Windows tablet. We're also scanning apartments and really pushing the limits of what can be captured now that we are on the Windows platform. So this opens up devices with a lot more RAM, and that allows you to capture much larger areas in a single scan. So this is an entire 2-bedroom apartment that was captured in one go using a Surface Pro tablet and the RealSense D415. So we're really excited to see this, and we're going to continue to push those limits of single scene capture as technology continues to progress. Lastly, we're seeing a lot of opportunities grow in terms of inspection work. So in this case, this is naval pier inspection work, but that applies across a lot of industries, oil and gas, construction, et cetera. And here's some outdoor capture with both the DT Research and a Surface Go tablet with the Intel RealSense again being extended very easily on a pole to get underneath the pier and capture that really hard to capture information. So that covers a brief presentation and introduction to both Intel RealSense and DotProduct. With that, I am going to transition over to Dot3D Live, and we're going to go ahead and go outside and scan. So here we are in Dot3D Pro. We are stepping outside at one of our employees' houses here because we needed outdoor Wi-Fi, and we didn't have that at our office. So we're actually doing this remote today. But we did set up a sample pipeline to scan as if we were capturing pipe out in the field. And we'll also be capturing a little bit of the house here as well. So I'll go ahead and press new scan. And we are now connecting to the D415. So you may see a warning on the screen here as to some frame rate difficulties recognized by Dot3D. We would not normally see this by any means on this device. This is only because we are broadcasting live to all 150 of you over GoToWebinar. So that's tying up a lot of the device's memory. So we're going to do a relatively quick scan due to that, but we did capture a much larger version of this just an hour ago as well, which we can take a look at. So the only targeting that I'm using here is an April tag for loop closure. So we actually have a cube April tag here that we're utilizing just because it's a lot easier than trying to tape down a paper target outdoors. But it's being utilized for the same purposes as if it was just a single paper target. So that's going to be my start and end point of my scan, and it'll tie in everything nicely to that point. All the green and yellow that you see on the screen is that real-time feedback on the quality of the data that you're collecting. So you can see what you've captured and how well in real time. So I'll continue to move along. It almost feels like spray painting. It is a very bright and sunny day here in Boston, which is probably the first time that we here at DotProduct had been hoping for a sunny day for a presentation, but we really wanted to show you this live. So it's working great here, even in the bright sunlight. So as you see the buttons on the screen here, on the bottom left here, we have the plane button. It looks like a paper airplane. That isn't so relevant for the outdoor scanning that we're doing today. But for indoor scanning, for staircases, for example, this is a really nice feature that allows you to flag flat surfaces in your scan or lock them in as parallel. So it could be two walls, floor, ceiling, even two different sections of the same floor that you're locking in as level parallel planes. But in an outdoor situation, you don't have as many flat surfaces, so we probably wouldn't be utilizing that button. But one button that we do want to use is the bottom right here, which is the HD photo capture functionality. So this allows me to zoom in close on the area of interest, and I can hold that to take an HD image of a particular area of interest. Maybe there's an equipment tag that I want to make sure I can read in my scan data, or an issue that needs to be flagged for repair, for example. So you can take those captures while scanning, and as you'll see afterwards, they show up exactly where you captured them in the 3D scan that you're viewing afterwards. So given the frame rate challenges while broadcasting live, I'm moving a little bit slower than I would otherwise. But in general, it's a very smooth walk through the scene, just making sure you turn green and yellow, whatever it is that you care about. So with that quick sample scan, I'll finish back on the target that I started on. And then I'll press that button on the right to finish scanning again. Now that we've finished our capture, we can bring the device back inside out of the bright sunlight and continue with our manipulation of the data. Everything that you see from this point forward could be happening on the tablet in the field as we're doing now, or it could be happening exactly the same way in Dot3D Edit, which would be our desktop version of the software. So you can envision this in either scenario. So there's everything we just scanned. This is the unoptimized format. This is where you want to just check and make sure you didn't miss anything important. Make sure you filled in all the areas of interest. And this looks pretty good. So generally the next step after capture is going to be to move on to optimization. Unless you would need to append or add areas, you can do all that, or implement targets. All those advanced workflows can be taken into account during the optimization. But in our case, all that we used was the April tag that we started and finished our scan at. So we're going to leave that box checked, and we didn't take advantage of any plane constraints, scale bars, or targeting otherwise. So I'll select Optimize Scene, and I'll let that process. So what's happening here is an overall improvement of the data set based on any targets that were utilized, but even without targets, it's going to be tightening the frame-to-frame alignment, leveling the colors throughout the scan. You'll see everything is cleaned up very nicely in this scan, and cleaning up any noise that's recognized in the data. It also would be implementing any of those plane constraints if you've utilized them. So basically any additional information that can be added before optimization is all being taken into account automatically. But in our case, it's just your basic automatic optimization, data quality improvement, as well as tying into that one April tag that was utilized as a start and end point. Just taking a peek at some of the questions now to give myself an advance heads up. These look like some very good questions that we'll address at the end of the presentation. So this optimization, same with all of the editing, does not have to be done in the field. So if you're trying to save time or battery life on the job site, you can save your unoptimized data immediately, and you can move forward with that. So here's our nice cleaned up scan. You notice all the colors are highly improved. All the detail is looking very, very nice and aligned now. This is our photo rendered view. We can also toggle to the point cloud view, which gives you a better idea of all the millions and millions of XYZ color coordinates that make up this laser scan file. The next step generally is to set your coordinate system. So I'm going to go to the Edit tab and set my coordinates. Our software is intelligent and will do its best to auto-detect a coordinate system, so it kind of recognizes that this is the corner of our scan. So it took a stab at it, but clearly it did not get our z-axis in blue going in the direction that we want it to. So we're going to reset that by pressing Set on the right, and you can pick origin, or you could set any known coordinate if you had a different XYZ you wanted to set it to, but we'll just set it to a 0, 0, 0 point. And then you can select by holding with your finger, and you get a zoom window to set that to the exact point that you want to set it to. Then you can set your z-axis straight up out of the ground by holding on the ground, and that pulls a axis perpendicular out of that. And you can set your x-axis out of the wall by holding on the wall. So now you have a coordinate system, and every single point within this scan is referenced to that. If you wanted to pull it in toward the scan, you could toggle it like I'm doing now, and now it's pointing in the way you probably would want it to. Everything's referenced to that origin point. Once you've set the coordinate system, I'm generally going to move from left to right on the top of the screen to go through all of the different options that you have as far as functionality over the next 10 minutes, and then we'll move on to questions. So if I go back to edit, I also have two different cropping options here. The quality filter is an intelligent crop that's taking advantage of some of that green and yellow feedback from earlier. So the areas that I didn't get as close to, didn't focus on for as long, got from a lower quality angle, et cetera, are automatically filtered out as lower quality points. And you can utilize this cropping filter to take some of those out however you see fit. So we'll just take out a little bit of that and hit apply. Next, if you want to do a more traditional crop, you go to Edit, Cropping, and you can crop anything that you point through this rectangular box here. An easy way to do this is go to the View tab and switch to Orthographic View to look straight on at everything, and then do a vantage point side, and that'll let me, vantage point side, and that'll let me shoot straight through. Oh, sorry, I'm moving around the go to webinar questions here and mistapping a little bit. So vantage point side, shoot straight through there and just chop off the top, for example. Now, if we look back around, we can check and make sure we're not cropping anything we don't want to. That looks pretty good. Oh, and it quit out on me. So that was a little too much for the GoToWebinar. Sorry about that. I will open this back up and continue from there. Of course, same with the live scanning, frame rate irregularities. You would not be seeing that at all if you are not broadcasting to 150 people. So every scan that we take is auto-saved as a backup. So I just want to pull up the scan that was just captured. Which would be this one right here. We had a backup scan that I could utilize as well, but that seemed to work pretty well despite the frame rate challenges, so we're going to use the real thing. I hadn't saved the coordinate system, so I'll quickly reset that again. Oops. Confirm, okay. And if I go to edit crop, do view orthographic, vantage point front, and just shoot straight through like so. can also clean up any stray points that you recognize, as we didn't apply the quality filter this time around. Otherwise, those would have already been filtered out. And that looks like a pretty good crop. Of course, you could get more detailed with this very easily. Again, everything functions the same, whether you're on a touchscreen like I am or on a mouse and keyboard. And you just press the bottom right to complete the crop. Next, I'm going to move on to the Measure tab. So if I go to Measure, Distance, this allows you to measure any point-to-point within your scan very easily with the tap of your finger. So if I want to get a height of this stone wall, for example, I can tap a point on the ground, tap a point on the wall, and that gives me my point-to-point distance, but also my change in X, change in Y, and change in Z based off of the axis that was set earlier. It's an adjustable endpoint, so if you want to move that around to get some different measurements, you can actually snap from point to point in the cloud with a nice zoom window to measure from any particular point of interest in your scan. And the units can be toggled to whatever it is that you're trying to measure to and from very, very easily. If I move on to the annotation tab, this gives me the ability to flag any particular point of interest within my scan. So maybe there's something that needs to be filled in this stone wall, for example. I can tag that stone to that particular point. Stone. And you add any detailed information that you want in there. And then that saves directly into your scan. It saves not only the text information, the XYZ information, but even the viewpoint you were in when you made that note. So this is really great if you're trying to take someone else who wasn't on the job site on a presentation through particular areas of interest in the scan. You can add several different annotations very easily. So we'll call this April tag. Again, any details you want to put in there and hit OK. And then if you double tap on these, it'll bring you on a 3D walkthrough of those different parts of your scene. Next, on the right here, we have the design compare functionality. So this is the exciting new capability to load a piece or a full CAD model and do an in-field registration and comparison of existing conditions to design conditions. We don't have a CAD model of the stone wall, unfortunately, but we have several videos out on our website on that functionality. Another feature that we definitely want to touch base on, which is new in the 3.1 and up release of our software, is the ability to capture those HD photographs while scanning. So if I go to View, High-Res Frames, we can see where I was standing when each of these HD images was taken. So obviously, you're only getting so much detail out of the color rendering here in the laser scan file, whether you're using the point cloud view or the surface-based rendering. But if you tap on these images, it'll bring you there in 3D, and if you hold on them, it'll bring up the high resolution photographs. You're obviously getting a lot more detail from that particular perspective, which is really valuable for a wide range of applications, from inspection to forensic documentation, and situations where maybe you would have been capturing a bunch of HD photographs in addition to this 3D scan anyway. Now you can have all of that information in a single compressed file with the added benefit of knowing exactly where you were standing when each of those images was taken. Currently, this is actually an HD photograph taken from the D415 sensor. You do always have that option, which is nice if you're extending it on a pole, for example. Although in our upcoming update to Dot3D, we're also going to be adding compatibility with Windows tablet cameras as well, which is majorly beneficial because oftentimes the camera built into your tablet is going to be much higher resolution than the sensor camera, so you're able to take advantage of both sensor and camera all on the same data set. And similarly, you can move around the 3D scan. It looks like I already cropped out some of that area, but I can go back and look at much more detail in the HD photograph. If you want to take some strategic screenshots, maybe of a measurement that you took, for example, or an annotation, you can snap those images straight from within Dot3D. It's capturing just the data, the measurements, the annotations, and cleaning out any of the menu items. And you can share that very easily with somebody just as an image file. However, you can also share the .dp file, which, as we've mentioned several times, is very highly compressed and can be opened up in Dot3D Edit or Dot3D View across platforms. So we're going to save as webinar scan 5 5 and press OK. And it gives you an option of what coordinate system you want to be set to. So we're going to be using the user-defined coordinate that we set with the tap of our fingers. The automatic detected coordinate system would be another option if the results were adequate. And you also see here two other options that are very nice. One would be if you had control targets, so if you had known coordinates that you referenced that had an origin of their own, that could be the transform. And the second would be if you performed that design comparison functionality. You can export this file, even if it was just to a small piece of a large CAD model, you can export this file based on that finger tap registration with the CAD. But in this case, we're going to use the user-defined and hit Save Scene. And that covers a brief and rapid overview of some of the functionality here in Dot3D, as well as a live scan outdoors on a sunny day, which is the most exciting addition to our lineup of products. With that, I'm going to pull up the questions. Yep. Yeah, and the other functionality that we have talked about but didn't necessarily show live is the append function. So as we mentioned several times, you can also go back and add more data into your scan on the fly, or build multiple scans together utilizing the append function, which in the past would have been required to capture a scan as large as the one I'm about to pull up, which is that apartment scan that was showed earlier. But now with the possibilities of powerful Windows devices, this was actually captured entirely in one scan, which is very exciting. And bear with me as I expand the size of these questions here on my touch screen. So we'll just take them in order here. So question is relating to the DPI line of products based on the PrimeSense. So they have traditionally required a 15-minute warm-up before you start your scanning, and this is a requirement that we implemented to get the most reliable and accurate results out of that particular sensor. The question is asking if that has improved at all, and in this case, it definitely has. There is no warm-up time required with the Intel RealSense. It is designed for this purpose and ready to scan as soon as you connect it to the software. The next question or request is iPad support, please. So we haven't forgot about it. So please stay tuned on that front. But currently it's Android or RealSense with RealSense, Android or Windows with RealSense for Android coming very soon, which we're excited about. So you could be snapping this very small sensor on the back of a phone, for example. We also are excited to be launching a product line very soon that will bleed the lines between the traditional DPI calibrated complete solution products and the Intel RealSense add-on. So stay tuned for that as well. So there's questions about the tracking camera and if this will help mitigate scan drift over larger areas. It definitely may be able to do that. This is something we will be implementing, but as of right now, the tracking and correction for drift is all contained within our software. We haven't implemented or taken advantage of the eye and the D35 yet, for example, or other RealSense tracking cameras. Is it possible to get a copy of the slideshow? Absolutely. We will be sending out a link to both a recording of this presentation as well as a copy of the presentation itself. So how does the new software improve on tracking while scanning? There's a lot going on behind the scenes here. We are always tweaking our algorithms to get better and better tracking out of each particular device that we're using. And we're currently optimizing for the RealSense suite of products, which track very well. And as mentioned earlier, we are looking forward to taking advantage of the inertial sensors, which will improve upon that even further. How long did it take to scan the entire apartment? That probably took about 15 minutes of just walking, painting the entire thing as we just did, but just a larger area. Although you should note that the optimization time significantly lengthens based on the size of your scan. So it took about another 15, 20 minutes to optimize. But again, that's not something that you necessarily have to do in the field. You can let that process, even in bulk, back in Dot3D. So how about drift? Simple question. A lot of our software is built in intelligently to compensate for that. That's in our core algorithms and technology. But if you are scanning larger areas, it is definitely recommended that you take advantage of the more advanced workflows. So if you really want to avoid drift, say you're scanning a long scan, a hallway or something like that, or a roadway or a pipeline, you can reference just the point-to-point distance of your start and end of your scan to an exact scale measurement and implement that before optimization, which pretty much negates drift entirely. It just relies on the accuracy of the device that you captured with, whether it be a laser disto, a total station, or a tape measure. Next question, is it possible to use the DPI 8X or SR, et cetera, outdoors? Unfortunately, no. I should correct myself there. It is definitely possible. We definitely have customers in a variety of industries using those products outdoors, but in that case, it has to be early morning, late evening, significantly cloudy day, in the dark with the light kit, or in a shaded, covered environment. The RealSense is the first product that avoids those challenges, and you can capture in even a bright, direct sunlight environment. The markers on the pipes, the question is, are those needed? No. So in fact, we did not do anything special with the markers on the pipes in this case. It's just demonstrating, what might be there, what you maybe could take advantage of if I had known measurements or if I had known coordinates between those targets. I could have referenced that information, for example. What should we make with the holes in the scan? So that is a great example of the append function. So any holes in the scan today would have just been an area that I did not focus on. And you could go back right away and append that right in on the fly. Just for the purposes of time, I was happy with what we captured today and move forward with it, but you can easily append back and build in directly into the same file very easily using the append capability. When April tags are used, how does it help align during optimization? How should they be used? So the April tags, as their base core function without any additional measurement or input, serve as loop closure. So anytime you loop over an April tag multiple times while scanning, it's going to tie into that point automatically during the optimization. So if you put up 30 April tags, but you don't ever hit one of them more than once, you're going to get zero improvement from those April tags. But if you put in one April tag, as we did today, you start at it and you finish back at it, that is going to provide a lot of improvement to your data by automatically tying into that start and end point. That's a large scale example of the loop closure. I'm not saying that you should only use one April tag necessarily. Whenever possible, you'd recommend that you put in, depending on the size of your scan, maybe 5 or 6 April tags for a room size scan scattered evenly throughout the space. And what that allows you to do is not only start and finish the same April tag, but periodically, whenever the opportunity presents itself, also loop back over April tags for smaller loop closures. And all of those are taken into account to improve the alignment of each frame of data during the optimization. So we've had a customer here who has had trouble finding a cord for the RealSense or something that is the right angle or short length. So please stay tuned. We've been doing some research ourselves into this, as for our particular application, the longer cable that comes with the sensor maybe isn't the best. So stay tuned on that. Next scan is an example of a long scan with an April tag that they started and finished at 50 feet or more along a continuous distance. You will get some drift in a scan like that, which is what the question contains here. So it would be recommended that you use maybe a laser disto to take a single measurement from start to finish of that distance, or a tape measure, and tie it in that way. And then additional improvements to our software as far as tracking, inertial sensors, GNSS compatibility, et cetera, might also be able to help you with that in the future. Can you extract multiple selected point-to-point distances and/or location measurements in bulk from the software? So currently, we don't have the export in bulk measurement of the measurements, but we expect to add that in a release soon. Our very soon upcoming release will give you the ability to export the location information of any April tags in your scan automatically. So you could place those tags on particular areas of interest, for example, which could be very helpful. Oh, looks like Kurt asked exactly that question. So yes, you can export the April tag locations. What is the hardware cost for the unit to connect my Surface Pro? So the hardware cost of the RealSense D415 depth camera, which is our recommendation for 3D scanning purposes, is only $150 available direct from Intel. We have a lot of questions here and are running out of time, so I'll just touch on a couple more. And as I mentioned earlier, we'll be sure to follow up with everybody individually. Is it compatible with terrestrial scanners such as Faro and Leica? Absolutely. So that's been a core goal of our technology from the start, and any of our product lineups are all very compatible with traditional terrestrial laser scanners, and we've partnered up with many of them to read our DP file format directly into their software, or you can always utilize other formats such as LAS, LAZ, E57, PTS, etc. What is the max square footage you can scan with the pending models? Technically, there is no limit into the size of a scene that you capture. But as mentioned earlier, even within a single scan, if you're going larger than, say, an apartment like the one we're looking at here, you're going to want to implement the advanced targeting workflows to tie into coordinates, to tie into point-to-point measurements in order to minimize drift. So if I was going larger than this, however, in this example that we're looking at here, we didn't even use scale measurements or scale references. We probably should have. That would always improve the results, especially if it was a larger apartment. But for this 2-bedroom apartment, it actually was just 9 April tags that were scattered throughout the scene. And we started and finished at the same April tag, which is always an important best practice, but otherwise didn't even rely on the more advanced workflows. And we got a very nice result. But the accuracy is always going to be highest if you tie into a known distance, known coordinate, you have that capability, et cetera. And all these options are made available to you in Dot3D Pro. With that, we're hitting the noon mark here, and I will be sure to follow up with everybody directly. We have quite a lot of questions here and quite a lot of very good questions. And you will be hearing from us over the next week or so. But before then, you will also be receiving a recording of this webinar, as well as a link to the presentation. Thank you all for your time on the line here. Thank you, Brian, as well. And we look forward to hearing from you further regarding these technologies.
Thanks.